Welcome and hello. This is a video tutorial in HEC-RAS, and in this lesson, I'm going to be discussing viewing sediment results. So once you've ran a simulation with sediment data, you're going to want to take a look at those results, and this is the lesson where we're going to be describing how to do that. All right, what I have on the screen here is the HEC-RAS 1D sediment transport online document. And here we're going to be discussing the contents of this viewing results page and a couple of the other pages down below here in the menu. All right, so let's get back to HEC-RAS. What I have already is a geometric data file that you can see here on the screen, as well as a sediment file, flow file, and I've already ran the sediment simulation, quasi-unsteady flow analysis. So what we have to do next is to go up to the view menu and then sediment output. There's also this legacy sediment output option as well, I'll mention at the end, but we're going to be focusing on sediment output. This is the newer and most likely the sediment results you're going to be looking for are going to be right here. It's going to be superior in most cases. If you've already done HEC-RAS, you know that a number of the other hydraulic related steady flow and unsteady flow results are in these upper menu options under the main view menu. But yeah, so for sediment, most likely you're going to want to go view and then sediment output right here. Right, so I've just opened up the sediment viewer, and what we have on the left panel is a way for the user to specify which results that they want. For instance, on the top left, we have the different variables. It doesn't say variables, but these are the different sediment related variables. And then below that, we have the mode. We either have time series, profile, or cross section, as well as a few other options. We're going to start with time series. After that, we need to specify the river and the reach. So I only have one river and one reach in my particular project, so that makes things easy. And then below that, we have the data for that selected river and reach. So right now, I'm seeing the different cross-section values, which is 1,000 down to 0, which coincide with the same river cross-sections you're seeing here in the geometric data here. Okay, so depending on the mode that we select, if I select profile, for instance, I'm going to see the different profiles or the time steps of the simulation. And then with cross section, I forgot. Okay, so we're back to river cross section. That makes sense. All right, so I'm going to, again, start on time series. I'm going to go through a few different examples of different results we can see in this main panel here. So with time series, I'm going to do a basic results, 2 cross sections, 2 variables, and then 2 plans, or it could just be more than one. So multiple cross sections, multiple variables and plans, and so on. All right, so let's do the basic results first. Let's just go ahead and select our variable. So I'm going to go with invert elevation. I'll check that. We got the river and reach already selected. This is going to be a time series mode. I'll select river station 600. All right. So what we're seeing here in the main plot is the plot itself. This is the results of sediment data. It isn't necessarily sediment data. Some of the variables refer to hydraulic data or some data that we may already have results to from steady flow or unsteady flow. But a lot of that data is also copied in to this particular sediment viewer for us to use for comparison. All right, what we're seeing here is the invert elevation of river station 600 happens to begin the simulation at an elevation of 30.8. Then over the course of the simulation, it drops down. And then about halfway through the simulation, it levels out at 30.58. And then towards the very end, it increases a little bit. So this is your basic plot. We have plot data here, the plot tab. There's also table data right here in a table tab. I'll talk about that a little bit more later once we have a little bit more data to look at. All right, the second example is to demonstrate multiple cross sections. So right now, checkboxes typically can be checked on or off independent of other checkboxes. So if I went ahead and checked on River Station 700 and 800 and 500 and 400, you can see that we have different elevations and then how those elevations, invert elevations of those different cross sections change throughout the simulation. I'm going to toggle off 700 and 800. And what we see here is the black representing River Station 600, magenta representing the channel invert of River Station 500, and then red for River Station 400. All right, so that's how to demonstrate multiple cross sections. I'm going to turn off 400 and 500. Next, I want to demonstrate multiple variables. So right now, we're going to keep our invert elevation toggled on. And then I'm going to also toggle on the shear stress variable right here. There's no shortage of variables to turn on. So if I toggle that on right now, these two variables share the same time window, that same horizontal axis. But now it's kind of hard to see. This shear stress is in light gray. It starts off at about 0.07, and that's pounds per square foot. Then it drops down to about 0.04 and then levels out for the most part. So when I'm looking at shear stress, I'm looking at this right axis right here. So 0 up to 0.08. And then again, that range for River Station 600 is about 0.07, 0.08 actually, and down to about 0.04. Okay, sorry about the colors. I'll show you how to update the colors in just a moment. Actually, one way to update the colors is just to toggle on these buttons right here. So if you click on these different buttons, it changes the color. But there are manual options to do it as well. All right, next up is two different plans. So what I'm going to do here is go up to options and then plans. Apparently this is a newer feature. I actually have a plan for 50 CFS, 100 CFS, and 200 CFS. So I'm just going to toggle on all three plans. And when I do, it actually deselects the variable and the cross section. So let's go ahead and just look at how about the invert elevation once again. So I'll click invert elevation, and then let's look at that River Station 600. Yeah. So now we have the three different plans here, where the black line on the top is the 50 CFS plan, the blue is the 100 CFS plan, and the green is the 200 CFS plan. So you can see how the invert changes with respect to time if the flow is a constant 50, 100, and 200 CFS respectively. Again, this is just one cross section. I could toggle off River Station 600, toggle on River Station 400, and get totally different results. But what I'm looking at is the same variable, invert elevation, and three different plans for the three different flow rates. By the way, if you're interested in building a model and looking at results just like this, I went ahead and recently created and uploaded a exercise 26. So it's in the HEC RAS exercise playlist. I'll leave a link in the description of this video to the specific file if you wanted to generate these same or similar results to what you're seeing on the screen here. All right, I mentioned the colors and doing manual colors besides just clicking on these two buttons. And the way to do that is right click on the plot itself and then lines and symbols. So this is a pretty cool way to change the symbology and the look and feel. What we have is the 50, the 100, and the 200. So if I wanted to change the 50 CFS to maybe something thicker, like 5 as the thickness, I can change the color right here to red. Okay, I don't want to do red because 100 CFS is red. How about we go with green? Okay. And I want to make sure that there's 0 symbols. I can then go down to the next series of data, which is 100 CFS. And I like that thicker color, so I'm just going to go with 5 here. And then 200 CFS. Okay, I need to click on right here for the line color. And then I'll just go with this royal blue, click OK, and then I'll switch it to 5 for my line thickness. There's a lot of other options I could choose from. Let me just demonstrate. Okay, so that looks good. That's what I'm looking for. Let me go back, though, to the lines and symbols. So for instance, I'm looking at this 50 CFS here. Instead of line, if I wanted it to be area, it fills the area in underneath the line. You may have some reason for doing this. I don't, at least not now. And then fill, I could change the fill to maybe a lighter green. So it's going to have a dark green line, but a light green area. Also, there's symbols I could choose from. So if I want like a square, and it looks like it's a magenta colored square, this is starting to look bad. Let's go ahead and make it a large symbol though, so I can see it. Okay, there's just too many data points here, but I'm just kind of demonstrating some of the features that you can use to change the look and feel of your diagram here. So if I click OK, this is probably going to be terrible. Yeah, it's pretty rough. Let me just demonstrate one more thing, and then I'll turn it back to some normal looking colors. Again, lines and symbols. What I want to demonstrate is we're doing current is our radio button selection here, but we could change the default plot line styles if we want. I'm going to keep it here to current, which is more of a customized way of doing it. And say, for instance, I really like this particular symbology and I wanted to copy it onto my different series. And this would save me the clicks of having to change the symbol size, the colors, and everything. So I would just go ahead and say copy line style. I'd select onto the next series and then click on paste line style. And now that 100 CFS series has adopted this beautiful symbology. And for good measure, let's go ahead and do the same thing for 200 CFS. All right, so if I click on OK, this really looks bad. So let's go ahead and restore the defaults. I think I can just do that by clicking on this button here. Okay, so that reset it. I mean, it's better than it was, but I need to still make the lines a little thicker. That's just my preference, though. While we're at it, let's go ahead and just discuss the other options when right-clicking on the plot tab. So zoom in and zoom out in full plot. I think this is all pretty straightforward. You can zoom in like this, right-click, zoom out. If you want to see the full extent of your plot and you're not already looking at it, right-click full plot will zoom you out entirely. Another way to zoom in, I've noticed, is just to drag along the axes. So for instance, if I'm only interested in the upper half of invert elevation values, I can just drag right here, and then it kind of zooms me in. Same with the horizontal. If I'm just interested in the first week or two, I could just zoom in like that. Right click and full plot. Okay, next up is pan and select. So pan is already selected. So with a single left click, I can actually pan around. That's what I'm doing. And then if I change it to select, I guess that just selects certain points, but I like pan better. All right, after that, we have point bobber, which I believe just highlights the different points. I think you can toggle that off though. Yeah, so then you're not distracted by all the labels that kind of pop up. But I'm a big fan of the point bobber. Also, you can copy the image of this plot to a clipboard. So if I did that and then I opened up like an image viewer or like Microsoft Excel, Word. So there I can go ahead and save the file that way, use it in a report. It pastes into Word as well, like I mentioned. Okay, the next option down is to tabulate. This would just bring up a little table. It's really the same data you're seeing in the table tab here, though. And then after that, we can fonts, sizes, and styles. So we can just change the font size of the axes and the title that way. And then what else we have? Grid and chart options. So the grid here, there's different options. We can just change the major and minor ticks and lines. And then the last option at the bottom here is chart options. So this is where we can kind of define the theme. This, what you're seeing here, is the default theme that's on the bottom. But if I like black steel, I can apply it. If I like it, I can click OK. If I wanted to view a different theme for the plot, okay, that's pretty much like default right there. Let's check out Chrome, apply. Okay, oscilloscope was the green one, I think. Yeah. So I'm just going to put it back to default, but just so you know, like the overall theme and background color is changed using this plot options menu. All right, well, that was it for the right click options on the plot tab. The table tab is pretty simple. What we're seeing here is the data for the 3 different plans. So if I toggled off a plan, one of these fields would go away. But if I toggled on another variable or another cross section, like cross section 500, boom, I just got 3 more columns of data here for the invert data corresponding to River Station 500. And I say it's 3 because there were 3 plans toggled on. We have 50 CFS here at River Stations 400 and 500. We have 100 CFS at River Stations 400 and 500, and then 200 CFS at River Stations 400 and 500. If you want to copy this data and paste it into Excel or something, just right click, copy table values with header. It'll paste into Excel. It's currently on my clipboard. And then, yeah, I guess that's pretty much it. So let's go ahead and go back to the plot. One more thing I wanted to mention about this plot here, and now we're seeing the River Station 500 data show up on the plot as well, is adding favorites. So if you like this particular plot, then what you can do is say add favorites, and I can give it a name, say something like 50 to 200 CFS, River Stations 400 and 500. Actually, I should really say ampersand 500. Hopefully the ampersand takes, and click OK. All right, so that's saved. Now, for instance, I wanted to just change it to just the 50 plan. That will cancel everything out. And if I just want to look at an invert or maybe something simple, that favorited plot should be right here, and it looks like it is. So now I can just very quick and easily access that plot. Okay, I'm not seeing the plan. Okay, so it looks like the plot doesn't preserve the plan that was selected, but it only preserves the data on this left panel here. So let me go ahead and select it now. Yeah, okay, so you have to manually select the plan. The favorited plot that we saved over up here preserves the data selection with the invert, the variable, the time series, the river, the reach, and then the selected cross sections. And if you want to clear the favorites, you just click this button right here. All right, so we talked about the time series mode already, as well as a lot of other things. Before we finish up, I want to describe the profile tab and the cross sections tab. So if I click on profile here, now what we're seeing is the profile data of our selected variable. at our selected time period. So now instead of the time period being across the bottom horizontal axis, what we have is the river station. Each cross section is represented by the main channel distance here. And what we have to select down here is not cross section, but now it's profile, i.e. time step. So this particular simulation was a 1 hour time step and it lasted for an entire month. So we have 744 hours or 745 records because there's one at the beginning of the second month. And what I have selected here is sort of the most basic example. We're using invert elevation again, just to keep it simple. We're using the profile, river A, reach 1. It's the only reach in the model. Let me squeeze this in a little bit here. And then we have the very beginning time step here. This represents January 1 at the very beginning of the simulation. If I wanted to do a couple more examples on the profile mode, I'll show you what that looks like. Say, for instance, we wanted to see what this profile looked like at the end of the simulation after the sediment transport has taken place and erosion and deposition has reformed this invert. I'm going to just scroll down to the last time step here. So after a month, boom, I've got all three plans toggled on here. Okay, I'm looking at a little bit more that I want. Let's just go with the 50 CFS and then click OK. Okay, invert. And then let me also toggle on that final. Okay, so in black, we have the original channel invert along the entire 1,000 foot long reach. And then the color blue here represents the channel invert after a month of sediment transport. This is a good way to show how the bed invert elevation changes over time. Can go ahead and select another time step here, maybe something intermediate. We'll say after about a week. We see this green line here now represents the January 7th. So this is 1 week into the 1 month long simulation. You can see it's probably closer to the original invert, but it's slowly making its way. It's starting to take a little bit more shape towards the final invert, which is blue. Okay, I'm going to toggle off the first time step and also toggle off that second time step. Instead of invert elevation, let's go ahead and look at some other sediment data. I'm going to toggle on the variable longitudinal cumulative volume change, which is right here. And already my legend over to the right is overwhelmed with choices because I'm actually exporting level 6 of data. So when I say level 6, I'm referring to, let me go to my unsteady analysis options, sediment output options. Yeah, output level 6 right here and also volume. So the higher the output level, the more data you're going to have exported and the more results you're going to be able to look at as far as like variables and then the grain size distribution as well. And then level 6 is the most. So let me backtrack to the results here. Okay, so I'm back in the results, and with all of these are actual individual grain sizes. Here, let me turn the invert off. Okay, if I'm only interested in the total, I can toggle off all the individual grain size classifications, and those get removed from the legend as well. So what you're seeing here in magenta is the total. But say, for example, I'm only interested in how about the medium sand? How about the medium sand, the fine sand, and the coarse sand? And then I'm going to turn off the total button because the scale was weird. All right, so the scale has now reset. And what we're seeing here on the vertical axis is the longitudinal cumulative volume change of sediment in units of cubic foot per second. So we probably wouldn't see much change at the very beginning. It looks like it's 0, but we would see more change across the entire reach length. So the fine sand right here is in green. This top line here represents the coarse sand, and then the bottom line here in light gray, this is the medium-sized sands. The reason why the medium-sized sand is much more than the fine sand is because I believe the specific gradation is very heavily weighted. There's a lot more medium sand than there is fine sand. Say, for example, I'm only interested in the fine sand right here, but I wanted to compare that fine sand cumulative volume change across the entire reach and see how it changes right now. So right now I only have the final time step toggled on. If I toggle on the first time step, it's just going to flatline at 0, right? So let's go ahead and just advance maybe 24 hours, and I'll select January 2, okay? And then let me advance another, how about 48 hours? So this right here would be after 3 days. And you can see like how 0 volume change is starting to become a 31 volume change 1 day or 1 week at a time. So right here is after 1 week. So you can see 1 week is about 90% of the same volume change as 1 month. If we wanted to, export this as an image, we can do that. I showed you how to do that. If we wanted to look at the actual table data, that's on the table tab right now. When using the profile mode, the table is going to be one row per cross section instead of time step. So you're going to have to think about it a little bit differently then. All right, let's go ahead and check out the last of the three modes I want to discuss, and that's cross-section data right here. And then I'm going to select both the beginning of the month and the end of the month. And you can see the change in the cross-section data. So I'm going to zoom in right here just to see that difference a little better. And then I could also change the colors. I don't like blue being used for the ground elevation because that's typically reserved for the water surface. And this is just as before, I can compare different cross sections. I can also toggle on different plans. I'm not going to do that, but just wanted to point it out that all these cross section data is available. The cross section mode would also offer some meaningful results, the same as time series and profile. All right, so besides the results we talked about in sediment output, there's also some legacy sediment output right here. And then your options are either version 5.0 or 4.x, and you can read what these different sediment output options are for you. The user's manual includes a table showing the comparative advantages and disadvantages of these different legacy sediment outputs. Okay, and then one last thing here in the user's manual. Again, this is the first link in the description, but if you extend the browser wide enough, you get this side menu on the left, and you click on output variables. This output variables table is pretty helpful because if you scroll down, then alphabetically we have the name of the variable and then the units and then a description of what it is. So if you're ever confused about what the variable is when you're looking at sediment output for these variables, or if you're curious about the variable when you actually assign the variable to be outputted. And what I mean by that is if you go to options and then sediment output options and then customize your variables, over here in the left list box, there's a number of different variables that may need a description. So you can go ahead and see the definition of what those variables actually are on this page right here. All right, well, that was it for this lesson. We talked about viewing results for sediment transport. We went up to the view menu, sediment output, and then we'd select the variable, the mode, the river reach and station, and then the specific data that we wanted to view the results for sediment transport in HEC-RAS.